Let's see, recorded this.
This meeting is being recorded.
I've noticed that, have you all, I don't think anyone in the night class, maybe someone in the night class have done captions, which was kind of cool. I don't know if anyone's noticed that you can do that. I don't know who's doing it. It's awesome if that's helpful. I wonder if I should be doing that. I don't know how to do that. Any questions on the 9-1 worksheet, number 3 that you got to work on between last night and, or the other nights and tonight?
They did ask a couple questions last night, and I think they figured it out.
Nice.
So
That's kind of what's the morning crew. Yeah.
Yeah. So Eric, just to let you, did you hear what happened? I didn't know. It was Reagan. Did Reagan talk to you?
Maybe.
Okay. I'll talk to you about it after class. And tell you what
Sounds
happened.
good. Okay. All right. So let's do 9-2.
Hey, Eric.
Yes,
Eric,
please.
just real quick on the 9.1 worksheet 3. I think a lot of us in the class were really confused about doing the formula, substitute, and result. Like doing that substitute piece was a lot different than in our notes, and so it was really confusing to a lot of us.
Let's do it again.
So, and we did, we did some problems with Cindy last night, and we all felt a lot, I think, I don't want to speak for anybody out of turn, but I think the general consensus was we felt a lot like it helped us to write out that substitute versus the way
I was doing it.
Yeah.
Yeah, great. Awesome. It hurts a little bit.
I told them if you didn't want to do the substitution, you didn't have to. But if you felt like it was kept you more organized, then just go ahead and do it.
100%.
Yeah.
So does that mean, let me make sure I'm understanding how you all would prefer to write it, because it doesn't matter.
And I don't want to speak for everybody else, but I think some others felt the same way. So I just wanted to.
So am I understanding that you like for this, so this is the 9-3 question we did write the answer to, number 5, and you want to write it like this. I don't know. Anyone know what Z alpha is for 99 point whatever?
What page are you on? Oh, you're on 5C.
Yes, I could have.
Okay. All right.
2.807.
2.807.
Perfect. So is this what you're saying you would like to do?
Yeah, that's how we did it in the notes. And so it was just really confusing me and throwing me. And I know a few other people said the same thing. So I just kind of wanted to point that out.
Love it. Do that. That's perfect.
Okay.
I'm so happy for that. The thing I want the most and that I want correct is this thing. And to me, writing this out helps you correctly type the stuff into StatCrunch to get this. So whatever makes the most sense for how you write this is perfectly fine for me, as long as you get this answer, which I guess I should pull that up. That's the most important one. And hi.
Will's got it for you.
Nice, thank you, Will. Copy paste. Does that, so that feels good for everyone? Because I remember we ended not super happy last night or Monday night.
Yeah, so that I didn't really understand what they weren't getting, but after like talking with them last night, it was just that. And I'm like, oh, so you guys, if you want substitution, do it. But if you guys are good not doing it, you don't have to do it. So
100%. If you wrote this and this, I would be happy. Actually, if you wrote this, I would be happy. Just don't get it wrong. The beauty or the helpfulness of writing these two pieces is I can see if this answer is wrong, I might be able to see why it was wrong and give you partial credit.
So I think for the night class, Eric, it probably would help, like with today's, is if you do that substitution with them, because I think
definitely.
That's what we figured out, what was confusing them.
Yeah, when we do something in the notes and then we're doing it something different on the worksheet with you, it's just like, especially when you're learning something new, we're just like, ah.
What? Like a course. Sorry. See, that's on me. Haven't we established that I am the problem? I know
No,
that's not what you're saying, but
I didn't
it's
say
good.
that.
I can learn too. Did I start the recording? I did. Okay, so then let's just jump into 9.2. I'm pretty sure you didn't get through 9.2 number one. Or you did?
I started it with the night class, so they've got to start on this one. So you can probably skip this one.
Okay, let's
um,
skip it.
I'm gonna just check with them and see how they did with it first thing in
Love it.
tomorrow.
This morning we did the whole thing
Okay, perfect. No,
for the
that's
morning
perfect.
people. So if you, for those of you here tonight, want to do it and then check the morning video, we did the whole thing. So let's start with the difficult problem. No, shame on me. Shame on
So
me.
Eric, you do have 9.2 worksheet number 2.
Let's start there. That's good, because then the morning
Oh,
people
you
we
can,
didn't do
no,
this
no,
one.
no, I get it. So you wanted to go to the hard problems.
No, but we need to ease people in. We need to slow our way in there. So let's start here. I think this is a good place. Making sure you can get the critical T values, which is one of the things I want to highlight, start with, is the difference between the proportion stuff and the mean stuff. So one big difference is the type of distribution we're using to find the critical value. So if you look at the formulas, here we have a Z alpha, Z alpha, Z alpha. And with the means, it's T alpha divided by 2. And how you find that, I know you saw it in the notes, but repetition doesn't hurt, is you use the T calculator, and you need to know the degrees of freedom. And you find the degrees of freedom with a super complicated formula, the sample size minus 1. And if you don't think you'll get that right, use a calculator every time. No worries. It is easy to forget that, right? Because you're like, oh, I just got to subtract 1. In fact, I did it in class this morning. I forgot to subtract 1 for one of them. So anyone need to see it in StatCrunch where this is? You know what? I'm just going to do it anyways. Stat, calculators, T. I did that fast. I've been drinking coffee late at night. Bad choices. Deep breath. Stat. Same menu we've been at in chapter 7. Calculators. That's where we used to go to normal. You go to normal for Z. But this time, whenever we're working with a mean for chapters 9 and 10, we go to the T calculator. It says T calculator at the top. Nice, good thing they labeled it. We're always doing the between, and we only need one thing, the degrees of freedom. The reason we use this is because there are 2 unknown things when we're working with a mean, or we need to know 2 things from the sample, the mean and the standard deviation. And so we don't know what that standard deviation is in the population. So the degrees of freedom allows us to make an estimation of it. That's why we need a different distribution. It's called the student's T distribution. All right. So do you think you can get these 3 answers on page 666 using this calculator? Let's find out. I'll give you 4 minutes. Set a timer for 4 minutes. I know it's early, 36 seconds early. How'd you all do? Am I rushing you?
Good, I think.
What'd you get for the, did you get, 1 point, how many decimal places? Doesn't say, 1.656 plus or minus for A?
Nope.
Did you get,
I got 6558 too. But I guess if I would have rounded, it would have been 1.6.656.
Right, Eric just rounded to 3. And you
oh,
rounded
did
to
y'all do
4.
4? If we did 4, it would be 1.6558. Yep, either one. Nicole, did you have something different than either of those?
I did, but I know what I did. I was doing n-1 for the DF.
So it turns out that simple little thing is like the biggest problem, right? Because either we give you a DF or we give you an N, and you got to remember which one to subtract from. So easy to mess that up. Yeah, I'm so with you. Good. So 1.6558 or 1.656, either way. How about the next one? This one, I'm going to use 33 and 0.92 to get 1.063. Should we just always do 4 decimal places? Yeah? No?
Sure,
Sure?
sure.
And then, so maybe it'd be helpful to write degrees of freedom equals 34 minus 1 to note we need to do that here. And maybe we should do that for C as well. Degrees of freedom equals 25 minus 1, which is 24. You don't like have to, but that's the big thing to keep track of with these critical values. And then of course the C level, it's easy to kind of mess with that one too. Plus or minus 3.0905. Okay, shall we do a tedious problem?
So yeah, just to let you know, Eric, when we did these last night, I didn't have them find X bar, S, and N. So obviously in this problem they did, because we used the formula where we used the standard error of the mean, and we just went and ran a t-stat, which doesn't give you the standard deviation.
Yes, fine by me.
So I said, if you're given a table of data values, you can just use the standard, and then we get a problem like this that,
I know,
oh,
right?
dang it.
So you all remember this problem from chapter 3, right? Let me pause. Why don't you all put in the chat yes when you've got the data in StatCrunch. I'm gonna actually re-enter mine because I missed the first one. It doesn't matter. I don't know why I'm gonna re-enter it when I could just cut and paste.
So we need to manually enter that, correct?
I think so. I
Okay.
don't know if there's one hidden anywhere.
Okay.
And then I don't know, does anyone remember summary stats?
Vaguely.
It's been a long time. It's been like since a
It seems
midterm,
like so long ago.
right? Remember when this was so difficult? Like, oh, how am I going to find the mean? What's the X bar? And now that's like child's play compared to the stuff you're having to do. So, okay, let me relax. Should I have more coffee? So we're gonna calculate these summary statistics. We only need 3. So you go to stat, summary stats in columns, just like chapter 3. I mean, this was the only thing we did in chapter 3, essentially. Well, remember we did regression. Y'all hated that chapter 4 stuff. Look at me not waiting. I just keep talking while I'm waiting for everyone to type in. So columns, stat, summary stats, columns. We're doing this just to remind you of what you did ages ago. We need mean. Did you remember that mean is X bar? Did you remember that standard deviation in StatCrunch and STDev and population standard deviation is unadjusted standard deviation? And did you remember that N is N? So there's our 3 things that we need from ages and ages ago. Now, it turns out to construct a confidence interval, we don't need any of that. We just need the data or that summary, either way. How we doing, everyone? This is years, by the way. If we were to put units on these, I'm often not super conscious of the units. I should be. And the units on the end is technically dogs or records, I guess. Okay, who knows how to construct a confidence interval? You know what? Have I not shown you this? If you want to construct a confidence interval and you have raw data, click Stat, T-Stats, 1 sample, then choose with data if you have the raw data, meaning you have a column of numbers. This is raw data. Or if you have the summary, click summary. Uh-oh, we have both. It's a choose your own adventure. Careful, if you choose the wrong one, you'll die in a horrible death. Y'all remember those books, like choose your own adventure books? So stat, T-Stats, 1 sample. I'm going to do with data first because that's what we have. I'm going to do it both ways and we'll compare them, but we'll start with this one. So when you do the with data, the menu says, hey, what column are you working with? It's variable 1. We didn't label it. Ignore this stuff. That's just for where you want the output. We're not doing a hypothesis test yet. We will. It's exciting. Instead, we're going to do a confidence interval for a population mean. Did we note our confidence level? Oh, here it is. Remember from proportions, it doesn't say confidence level. It says a 95% confidence interval. So the percent is the level for the confidence interval. It's just how we write it. Maybe we want to see what the critical value is. So I'll click that. Not particularly necessary, and then compute. Note, when we have the data, we just have to select the column and state the confidence level. That's it. That's all we have to type in. Compute, and here's the result. Note the sample mean is the same as the sample mean here. Now the standard error, do you remember the formula for the standard error? No, that's the margin of error that I'm thinking of. Let's not bother with the formula for the standard error. It's S over the square root of N. So if we wanted to find S, we would do the square root of N times the standard error, and we'd get this sample standard deviation. In other words, 4 times 0.65112083. Oh, look, 2.604. That's the same number as this number. Okay, so how are we going to write this down? So here's what we were talking about where I confused you all last time because it was different than what we did in the notes. First, I'm going to write the formula. X bar plus or minus. Now, I know what Cindy said, and what's what we're going to stick with is you're going to do the critical value. And we're picking this because, or we clicked the show us the critical value in the menu so that we could do the substitution. And then we're going to write the standard error of X bar. Now you can write it that way, or if you don't like how that looks, you can write it the way I wrote it all the time in chapter 8, the standard error of X bar. Which way did you do it in the notes?
The SE of X bar.
Which makes sense because that's what's right here, right?
Exactly.
So let's stick with that. Ignore that I did this because that'll probably confuse you. Or just make you think a little more. Maybe it won't confuse you. I don't know. I don't want to. So let's stick with that one. The standard error of the sample means. Okay. We know all three of these numbers right here. I'll write it below. In whatever this color is. Pastel purple. That's exactly what I was going to say. Nope, not going to do that. We'll do pastel pink. 5.125, there's our X bar. Plus or minus, I'm going to use parentheses here for the T critical. I'll do 3 decimal places for everything. 131, and then my standard error. 0, what is going on with this computer? 6, 5, 1. There's all my substitutions. And that can be it. Which is 2 less numbers of writing than if we were like, hey, do this formula and say X bar T alpha S and square root of N. The reason we're not having you do that one is because you have to find the sample standard deviation using the summary stat. So it's one more thing to click through and remember, and let's just not bother. And then the main thing we wanted is this lower limit, upper limit. Dark green. Oh, it's like one of my favorite Lego colors. 3.737, comma 6.513 years old. Is everyone happy with that?
Yes.
Is that a decimal point after the 6 and between the 5, or is that not a decimal point?
It's trying to be real hard. Thank you. Fail. Triple fail. Okay. There's a set down here, Emma. Okay. I think, sorry, I shouted that, didn't I? I think I'm going to let you try these two real fast. I think you can do them. It's okay if you can't. We'll talk through it. Why don't you try it? Let me give you 5 minutes. Maybe that's too much. Maybe it's not enough. We'll find out. If you're done before I start interrupting you, let me know. Set a timer for 5 minutes. Okay, that was 4 minutes. It was agony. I did it. Anyone have a sentence for me for C?
I'll try it if nobody else wants to.
Go for it.
We are 95% confident that the true, and I don't know if I have this part right, but population proportion of the age of all canine clients is between 3.737 years and 6.513 years old.
Nailed it, except for the one word.
The proportion.
Is this a percentage? Are these numbers percents or are they something else?
They're-
It'd be the population mean, right?
That the true population mean age of a dog being groomed, blah, 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 is between 3.737 years and 6.513 years.
I think I subconsciously knew I had that wrong, but didn't listen to myself.
That's okay. That's okay. Couple clues, because this is a really important part that you all are learning, and it takes time to put this together. When do you know you're working with a mean? When do you know you're working with a proportion? Dead giveaway that it's a mean, a data set. We don't give you data sets for proportions. We could.
Yes.
We don't. The other giveaways are the X bar and the S. And the fact that the numbers we're getting have units on them that are something other than a percentage. Proportions are always just a percent of the success divided by the sample size. So when your confidence intervals do not have numbers between 0 and 1, it's a mean. Was there another one? Yeah, so in B, we didn't actually say what type of confidence interval. A lot of times we say confidence interval for the mean, and we use mu because that's what this is, the population mean. In fact, that's what the symbol for these three words, which true and population are kind of, true is just like to really emphasize this is where we think it is. This is what we think the actual number is. Cool. Everyone happy? Or only slightly annoyed? I'll take that. Okay, now the super tough question. The dog groomer says that on average, their clients are less than 7 years old, clients being dogs. Does our interval support or contradict this dog groomer's claim?
I put that it supported it
Good, why?
because the entire interval is below 7.
That's it. Because the entire interval is below 7. The other thing you could note, in fact, the only number that matters, love it, is that the upper limit is smaller than 7. I like what you said though, Sarah, that it's the entire interval. Every single number in that interval is below 7. Nailed it. That's exactly right. The only thing we have to look at is where is the 7 relative to this upper limit, because a less than claim needs to have the number above the upper limit. It's not above. If it's within or below, then it contradicts. Good. Okay, now I'm ready to shove you off the cliff and see if you spread your wings and fly. So I'm skipping around a little bit. Jump to page 665. And I'm dumping in the chat the link to this data set. So if you click that link, you may have to copy and paste it if your default browser is not the one that you have your StatCrunch password saved in. If you click the link I dumped into chat, it will open this up so you don't have to type anything. It'll look like this. This one has one extra question to it that you didn't just do, and that is you have to verify the conditions are met. So just a quick reminder of what those are. Excuse me. They are these three conditions here. And I'm wondering, does anyone remember the name of this graph?
Normal probability plot.
Nice, Sarah and Nicole. I think I saw that, Sarah. Good.
We debated that, like, I'm like, oh, you guys, Eric has specific name for this thing. I
Normal.
don't know why I can't remember the name of it.
I know. Should I really bother with it? Okay. And what does it have to be in order for this thing to be, or what information do we get from the normal probability plot? Sounds like y'all don't need me to refresh you on this.
Approximately linear.
Yes. Approximately linear. This is the 7-3 section that we did real fast. And it was like, hey, look at these graphs. If the normal probability plot is approximately linear, then the population itself is normal. Okay, 5 minutes, see if you can't get A and B. And if that's not enough time, we'll extend it. Set a timer, 5 minutes. So that was 5 minutes. Let's just check. Y'all got C1 random, not known. Given, just kidding. That's the one that everyone should get a point on the exam. I'm going to be very upset if someone doesn't get that point. Very upset. What'd y'all say for independent? It's not.
I just left it as the equation because it came out as like 0.98 or something, which made it not.
Oh, but remember it's millions, so it's 0.98
Right.
million.
So
You're
that's
good.
why I just left it as the equation. So
Love it.
yeah.
You can live with that. Yeah, I agree with that. We kept saying that they never give you the numbers, and like every problem we've done, they've given you the numbers. I guess we didn't know. The other thing is you could say all Capital One users, customers. Sounds like drugs. COCs. That's another thing. If we didn't have a number, you could say that. Good. And what did you say for 3? This is the one that I'm most curious about. Did you
Well,
say no?
It's not normal, but it's a normal probability plot.
So
Because
do you
7
think
is not?
right? So the sample size isn't large enough to guarantee a normal distribution of sample means. If we kept collecting samples of size 27, the X bars themselves might not be normally distributed. But what does this tell us about the population itself? Or how do we read the normal probability plot? You're just gonna wait till I write it. That's totally cool.
It's approximately linear.
That's it. The normal probability plot is approximately linear, which means which means that the population is normal. So if you remember from chapter 8, either you had to have a normal population or you had to have a sample of size 30 or greater for means. For proportions, it just had to be NP and Q had to be greater than or equal to 10. Whether the population was normal or not wasn't helpful.
So when we write this answer, if we have an answer like this again, Eric's, should we also show that that 27 is less than 30, or
You don't need to show
should we
that because
show? Okay,
we don't care about that because we know the population is normal.
okay,
So because our graph is telling us, hey, we're drawing samples from a normally distributed population, thus the sample means that we draw, regardless of the size, will themselves be normally distributed. We're good to go.
okay.
Do we have to put on there that the population is normal, or is it okay for just to be a normal probability plot that's approximately linear?
You can just say, yes, this is normal, or because the normal probability plot is approximately linear, this is meant. Yeah. So you don't need to say this, but that's why this graph is here. It's telling you that the population is normal. I need to know that you know that graph is telling it to you. Turns out, right, if we ever give you a graph here and we say verify, the graph is going to tell you it's going to be approximately linear. And we could debate whether or not this is approximately linear, but it looks pretty good. There's a little bit of a curvature here at the beginning, but it's good enough. Did you all get to B, or did you need more time?
I'm like halfway through B.
Well, let's give you more time. So how about I do 5 minutes and you see how far you can get with B, C, and D. Set a timer for 5 minutes. You'll need StatCrunch for B. All right, where are we at? Um, okay, so I'm assuming you all went to stat, T-stats, one sample with data. You grabbed the credit card debt. You said this was a 90% confidence interval. You clicked the show critical value because we want to show that for the substitution, and you clicked compute, and you had this as your lower and upper limits. 12,362.05, since this is dollars, 18,089.14. Does anyone feel like they need to see the substitution, the formula and the substitution?
I'm good.
Good. Wait,
Okay.
did someone say yes?
Actually, if you don't mind, is there any way you could? Because I somehow got something a little different. I'm not really sure where I messed up at.
You got something different here?
Yeah, but I think because I went and for whatever reason I tried to go through the with summary and then I had to go back and figure out what I did it the hard way instead of doing it with data, and somehow I messed up in there somewhere. But I mean, I now that I redid it, I got what you got.
So you use these numbers is what you're saying.
No, I still got that different. I don't know what I did wrong. Maybe I inputted something completely different.
Did you type the data values?
No, that I didn't do.
Okay, good.
But I did just do it, and I got what you got with using with data. So
Did
somewhere
you,
along the way, I just
my
pushed
other
something.
guess is whether or not it was a 90% confidence interval. That's a common.
That could have been where I went wrong.
Here, I'll redo it with a 95. You can see if that looks like what you had gotten. Does that look like what you'd gotten?
Yes.
Okay, so that's what it was. You forgot to change the 95 to a 90. I did that this morning. No worries.
Okay.
Excellent. Okay. Did you all right? We are 90% confident that the true mean, the true population mean amount of credit card debt carried by Capital One credit card customers is between $12,362.05 and $18,089.14.
Nailed it.
Yes. Okay, I got it right. I love it. You learn well. I love it. Alexa, talk to me. What did you not get? Oh, okay. I mean, you don't have to have, I said a lot of extra stuff, right? I said, you could have just said the mean credit card debt is between. I cut someone off. Go ahead.
No, I was just gonna say I didn't put in Capital One, whatever.
Yeah, that's okay.
When we are interpreting this, do we have to put in all the extra words to make this interpretation like super long and extravagant, or can we just be like straight to the point and
Just make sure that when you're straight to the point, you're like, it's credit card debt. If you just say the true mean of the population is between these two numbers, you're not really telling me what the numbers are. So as long as it's like it's dollars and it's debt, or it's dogs and it's 8 years old thing. Does that make sense?
so we could have put just credit card debt. We didn't have to go in
Right.
to be like credit card debt used by Credit One consumers, whatever.
No, you don't have to have all that. Because
Got it.
once you state it's credit card debt, I know you know what you're talking about.
Okay.
Like I don't care if it's Discover people or Visa or American Express, right? Like whatever. Good. Okay, what did you say about the claim?
It contradicts it.
Contradicts because
18,000 is within the interval.
that's it. Anytime you have a less than or greater than claim and the 18,000 is between the lower and upper limits, it's a contradiction. It doesn't matter if it's greater than or less than. The only time that a within value supports is if we're claiming equal to, and that's it. It sounded like I was going to say more.
Okay, so that number would have to be below that interval. Below. Okay.
Well, so actually this
Or-
number would have to be, since it's a less than claim, it would have to be greater than the upper limit.
Greater than, okay. So I
Because
wrote
then
that
the,
in my notes and then I was like, did I write that right or not? Because it didn't. Or wait,
it's
I don't
weird,
know.
right?
This confuses
Less than
me.
has to
It's
be
like,
above, greater than
I feel
has to
like
be
it's,
below.
yeah, I feel like it's
Opposite.
easy, but it confuses me for some reason. I don't know why.
No, that's a common thing to be confused by it.
It's the
don't feel bad.
verbiage.
I think
It's the
Sarah has
language.
it though. You've got it, Sarah.
I have it this go around. The last time we had to do this contradict or whatever thing, I was like, yeah, okay, this one looks good.
Guess and check. I like to leave them blank and make you write it out instead of giving you the options. Like I liked the one back here in the 9.2 worksheet where you just had to say whether it supported or didn't. Sometimes that's easier because you don't have to like read each one and figure out which one exactly matches what I know it to be. It's like, I know it's this, but if you're not reading carefully, like this morning, I circled support because all I was looking at was within, and I wasn't I knew it was contradict, but I just saw the within and circled that. So
Yeah, that's where my mind went.
I will probably not give you these options. And let
That's
you
good.
just,
I think
really
maybe
nice
you're-
and give us those options.
you would
I think
prefer
it's
them?
I think it's easier to write it yourself.
I think so too. And then you don't have to use the exact language. Because you could say contradict because the upper limit is above the 18,000. You know, there's flexibility and how you show that it contradicts. All right, so we did the whole thing problem. So now we can go back and fill in all the little tiny gaps. So here's another one that's a whole thing problem, number 3 on this same worksheet. So this is 663. And this problem has one slight change to it. We give you the output, except we didn't give you the critical value. What? I bet we're going to make you find it later. And for whatever reason, we got rid of the sample mean. We didn't put it there. And of course, we're going to ask you to calculate it. So let me remind you of some language. Anyone know what a point estimate is? And I'm not just pulling this out of thin air. It's literally question F, compute the point estimate. So when we say point estimate, what do we mean? And maybe this would help. Where is the point estimate in a confidence interval?
It's in the middle.
Nailed it. So what is it?
I don't know the number in the middle between the lower limit and the upper limit.
So is it a mu? Is it an X bar? Is it a P? Is it a P hat? Is it an S?
P hat.
Is it a sigma? It's a
P
P
hat.
hat. Is it a P hat in this problem? Okay, I'm being a total jerk. I got to stop. It
I
could be a
plead the
P
fifth.
hat.
It could be any of those. It depends on what the sample is.
Nailed it, 100%. It could. So for us, we only look at 2 things: P hats and X bars, means and proportions. So the point estimate is the sample statistic. That's redundant. It's the statistic, meaning the calculated value from the sample. So if we're working with means, which this tells us we are right here, then the point estimate is X bar.
Mhm.
If we were working with proportions, then the point estimate would be P hat. So point estimate is a general term, and it is the exact center of the confidence interval. So if we know the lower limit and the upper limit, how might we find this point estimate?
Isn't it the upper limit minus the lower limit divided by 2?
Love it. Almost.
Or is it addition and then divide by 2?
Because there's 2 formulas, right? There's one where you subtract and there's one where you add. Which one is it?
You add.
It's the adding, because how do you calculate a mean of a data set? You add together all the data values and you divide by how many. This is a data set of 2 numbers. So we add the 2 numbers together, we divide by 2, and remember the mean is the middle. if it's normally distributed. Well, this has equal distance between the center and the upper limit, the center and the lower limit. So we're calculating the mean of the confidence interval. The subtraction one is actually the margin of error.
Okay.
Okay, so now you know how you're going to get your X bar for this problem. That was the one I expected you to get stuck on because it's the only one we haven't done in these problems yet. I know you did it in the notes, but we haven't done it here. So
Okay,
what?
oh,
Go ahead.
Eric, can I just have them, you guys try using your page 223. So I see that you guys are like, some of you are like fumbling through pages. Try looking at your 223 that we filled out, because that should have like all this stuff that we've been talking about all in one spot for you. Just try it, see if it works. If
So
it
this is what
doesn't,
223 looks like. Yeah. And you can bring this to the final exam if you want, these flow charts. I'm okay with that.
if you guys don't have that filled out, we filled this out last night, last thing, so it will be in the Tuesday night notes.
So 11:08 near the end.
Yep.
Okay, I'll put a timer on the clock for 5 minutes to see, and I'll check in. The goal for you is to do number 3 from A all the way to J. And you don't really need any stat. Well, you'll need StatCrunch for E. Other than that, you should just be able to read the output.
Quick question, how
Set
many
down 5 minutes.
decimals are we going with the mean? Are we gonna follow what they have for the lower limits and go that many if there's that many?
I'll do 2 or 3 or
2 or
1.
3? 1, which is Eric, that was 3 separate numbers.
Which one do you like the best?
Oh my
Do 3.
Do
Thank
3.
you.
Okay. Sorry, that was very hateful, wasn't
God.
it?
It just doesn't.
I
I'm
said the
still
same thing to
coming
him
off
last
the
night. What do you guys
other
want to do? I said the exact same thing, Eric.
Okay, thank you, 3 it is.
3 it is.
We are very literal people, Eric.
I understand.
And I'm sorry, what problems are we doing again?
You're doing number 3 and see if you can't
Okay.
go from start to finish. I'm
Okay.
not expecting you to be done in 5 minutes. I just kind of want to check in and see how we're going. So 5 minutes is up. Do we need to check in on anything? Did you all get 50 movies? And 6.5 million movies?
I'm not really sure how to do this. I'll be honest. I'm
Okay, talk to me.
yesterday, and I'm not really sure what we're doing. I need to go back and watch the notes.
So this first question, I forgot. This is also one that can often forget folks or get folks. Do you remember that the degrees of freedom is n-1? So what is n equal to then? +1, +1. Degrees of freedom +1. So we didn't give you the sample size, but we did give you the degrees of freedom. So the sample is the number of movies that are collected in the data set or in the sample from IMDb. And the amount that we collected is 1 plus the degrees of freedom. So that's where the 50 came from. The population we told you right here, 6.5 million. 6.5 million movies on IMDb. I wonder if that's all that were ever made. Probably not. Is that okay?
That actually makes sense. Thank you.
Good, good. Yeah, sometimes it's like you just have to see these talk through because we're coming at the problem from a different angle. All right, what conditions did you check?
It is
Random.
Give-
Random, that's the one everyone's gonna get. Is that given? Yep. Independent, is it independent? Yeah,
Yes.
50 is less than or equal to 0.05 times 6.5 million. Is it normal?
Yes,
Yes.
Why?
because 50 is greater than 30.
Love it. Okay. Did anyone find the confidence level? It's hidden. It's actually in the same spot that the printout always gives it. You just got to get comfortable seeing it right here.
Oh, the 98%.
Nailed it. Now, what's the connection between the confidence level and alpha?
I have no clue on that one.
Oh, I'll write a little formula just for fun. Let's see. One way is C level equals 1 minus alpha, or we could solve that for alpha, kind of like we did with degrees of freedom, and alpha equals 1 minus the C level. They're complements, kind of like P hat and Q hat. Same thing.
So would alpha be 97?
No, because I see why you think that. I get it. Think 100%. So I wrote it in decimal form here when maybe I should have written the formula. Curse words. Maybe I should have written these formulas in percent form. Boy, I just can't do it tonight.
So it's 2.
Nailed it.
Okay.
Oops. I need a new phrase, don't I? I don't know. I gotta be careful because I'll say something crazy. Drop a cuss word or something. Okay, excellent. Did you all get this far? Should I pause and let you keep working, or did you all get the confidence, the critical value?
I'm not that far. I don't know about anybody else.
Okay, let me 5 more minutes on the clock. Set a timer for 5 minutes. For this one, don't forget you're going calculators and T calculator for E, and you need your answer from D to help you with that.
So is E going to be just like the critical T values on our appendix on 271? Okay.
100%, exactly the same.
Gonna give that a shot.
All right, that was a little more than 5 minutes. Did you all get? Plus or minus 2.4049?
I did.
Yes. Nailed it.
Now, as far as graphing and putting all that stuff in, you just want the graph and just labeled where the middle and the two sides are, and just like it showed us, and yeah, just like
Yes,
it's
you can just
thing.
follow what you did in the notes. Mostly, I'm happy to see that you could find that.
Okay.
Because I know, like, if you found that, I know you see the graph. Like, I know you're looking at it.
You're missing
Unless
a
you looked at,
I was gonna say, is it 2.4049?
yeah.
four-
see,
Yeah,
there's
there's a 4 between
there's
the
that
0
other
and
4.
Okay,
There it is. Sorry, I got lazy with writing it. Good. Did you find the point estimate?
yes.
What'd you all get?
102.2?
Yes, that sounds right. Yeah, 102.2. Excellent. Did you find the standard error?
No, I got confused on that one.
Copy and paste.
2.110.
Oh, it's
Good.
right there.
It's right there, right. Like sometimes that's the hardest part is the ones that are just, we hand it to you. You're like, really? Is it that easy? And yes, the rounding on this one's a little bit annoying. If we do 3 decimal places, that 5 changes the 9 to a 0 and changes the next 9 to a 0 and changes the 0 to a 1. Talk to me.
Sorry, I got that one. It was actually the next one I was confused on.
Right. So the next one, is there a little formula for margin of error that we sort of know, a general formula like critical value times the standard error? That works for whether it's a proportion or a mean. What's different is with proportions, the critical value is Z. For means, it's T. We just found a T critical value and wrote down a standard error value, multiply the two together, and you've got it.
So say that again.
Did you want me to do it?
Sure.
Yes, please. Is it kind of like the one we just did on that other sheet?
So it's
5.052029. It's like the one we did.
566.2.
It's what you did last night.
Oh, okay.
Right here, number 6. You did it 3 times right here. In 3 different ways. And in some of these, it's this one is the most similar. Because these other ones, you had to calculate the standard error by doing like 5.1 over the square root of 38 and then multiplying that amount. So this is the standard error times the critical value. This problem is a lot simpler because we already know the critical value and the standard error. We knew these 2 numbers, multiply them together, you've got the answer. Quick word on notation. Have you all been doing in the notes? I'm pretty sure you have, using E for margin of error. Yeah, I keep doing ME. I need to use E because that's what we use. And that's what we use in 9.4. So if I ever write ME, tell me, no, that's not what it is, Eric. Erase that M and that dot. It's the letter E, capital E. So it's the critical value times the standard error. I don't think I need to bother with I. Do you all think I should bother with I? You're 98% confident that the true mean length of a movie is between 97.151 minutes and 107.249 minutes. And apparently that new Avatar
Can you
movie.
type that down? You're going a little too fast for me.
Oh, okay.
Yeah.
Talk to me. Where's the last answer that you have written on your paper from when you were working?
I was working on
Okay, what do you have?
we are 98% confident. And then you kind of said it a little too fast.
Keep going. I'll pause. I'll let you write it.
Okay.
I was just saying for you all to check it. So yes, thank you. Slow me down. Let me give you 3 minutes to answer I and J, since I know that's where you all are at. Set a timer, 3 minutes. Thank you, Kayla. You all got to call me on things. Ooh, that was 3 minutes. Okay, what do y'all got?
We are 98% confident that the true population mean of movie lengths is between 97.151 minutes and 107.250 minutes.
Delicious. Is that good, everyone? Everyone got that?
Yes.
Anyone not have that? How about J? Oh, let's see, chat. More or less. Okay, yeah, it doesn't have to be exactly the same. You're like, hey, movie lengths, the average movie length, the true mean average movie length is this and that. Yeah, it's the length of movies. As long as you got in there that it's how long a movie lasts and that these numbers are minutes, I know you know what the context is, and that you keep track of how confident we are. Excellent. Hour and a half. Anyone know how many minutes that is?
90.
90.
Good. If you didn't figure that out, how could you answer the question, right? There's an hour and a half in between these without knowing the minutes. So what's your thing. If it's lasting longer than an hour and a half, longer than 90 minutes, does it support or contradict?
Contradict.
Because,
That's what I thought too.
The entire interval is below 90 minutes.
well, let's see. The lower limit is 97 point something. The upper limit is 102 point something. Where is the 90 minutes in relationship to that? Alexa, why'd you say support?
Within the time interval.
Because it's below 97. Okay, right. So here's the 90 minutes. Like if I were to draw the
Oh,
interval,
longer than.
Oh.
yeah, we're down here at 90 and they're like, hey, movies are longer than 90 minutes, hour and a half, longer than
I'm
90,
reading longer, but I'm thinking less.
right? So this is below the smallest possible value for our movie, our mean, you know, the mean of all the movies. So yeah, definitely supports it by
This
7
question is
minutes.
really starting to pee me off.
Yeah. Anything above would be longer, yes. So
Darn it.
if your claim is longer, you're looking for the number to be below the lower limit. It's the
So that's a
opposite.
support statement?
So this supports because 90 is below the lower limit. Because we're saying, hey, these movies, they last longer than 90 minutes. And we're like, okay, what is the shortest possible mean movie length from our interval? It's 97. Is 97 bigger than 90 or smaller than 90? It's bigger. So yeah, our confidence interval is saying that the shortest possible mean length is 97. It could go all the way up to, did I get the wrong number? 107. Which, like, I mean, it's not that many more minutes, but I mean, if you watch the Lord of the Rings one, right? Remember the very last one? It's like, oh, yay, the Eagles did the thing and the movie's over. It's like, nope, here comes some hobbits doing things. Oh, yay, it's over. They're all happy. Nope, now they're going to the boats. And if you've read the book, yeah, that's what happens because they defeat Mordor and then the hobbits go back and have a whole battle at home. Great story. Great story. How y'all feeling about this?
Well, I was feeling good until
So this one,
the last one, yeah.
let me see if I can try something. I don't know if I did this already. If I did this already, stop me, because then if you've already
Kira,
seen it.
if you change that word longer to greater than, would
Oh.
that help you understand it? If you,
Yes, it does.
Nice.
It's the verbiage.
So that will happen. Longer than and greater than mean the same thing. So if you're attuned to greater than, less than, or equal to, and you see the words and interpret them into that, and then you're ready to roll.
I have a question about H.
Yeah.
Is the answer for that 5.050? Hey, you already got
That's
it.
what I get.
Okay.
Good. You did 2.4049 times 2.1, right?
Yes, I did.
Ish. And there you go. Good, good. Critical value times the standard error. Good job. Okay, so we got 19 minutes. Love it. We did the big problem here, crushed it, nailed it. We did the other big problem here. We have some minor questions here left to do. And I call them minor because they're little pieces. Like here's a couple, can you get the critical value from StatCrunch? This one, let's do number 2. I want to see if you can figure that one out. Let me put 3 minutes on the clock, not to rush you, but to keep me from talking, and see if you can't put this together. This is a conceptual, sort of a conceptual question. Can you read the pieces that are handed to you? There's very little calculating needed to be done. Set a timer, 3 minutes, go. 3 minutes, go. What'd you get?
68.8 and 85.2.
What? How'd you get that?
I added 8.2 to the average 77 gallons, and then for the upper limit, and then subtracted it for the lower limit.
Okay, so nailed it. Yes, awesome. So this we know to be the point estimate. This we know to be the margin of error. And we know that the upper limit is equal to the point estimate plus the margin of error. And the lower limit is equal to the point estimate minus the margin of error. Good, good. Most commonly missed question on the final exam in my experience of grading, because you get so accustomed to doing this stat crunch thing where you're like, I just have to put in these 3 things or these 2 things or run the with data thing. And you forget that if you know the point estimate and the margin of error, you just add and subtract. Or if you know, I guess that's the main one we do. And so, yeah, there's almost every year there's a question on the final exam that's just exactly like this, where we give you the information to build it. We give you what you need to just run this quick calculation and write it. And students are like, I've often get notes. I don't know how to type this in StatCrunch. I'm like, oh, you don't need to. It's right. You need to understand what a confidence interval is, how it's put together. It's this E in between here. It's this point estimate here. It's this lower limit and this upper limit. And I got those backwards. Of course I did. That's what I get for talking and writing and thinking and whatever. Okay, boy, I feel like we've done it, but we got these solid 13 minutes. So please.
5.2, but what was the other one? Because I had
what is 77 minus 8.2?
It's 68.8, so that's what I got.
That sounds good. 68.8. That sounds about right. Yeah.
All right, thank you.
And these are gallons of coffee per year. Oh boy, I didn't even read the context. I don't even want to know what I drink, how much. I get migraines every once in a while, and then I was reading like triggers of migraines, and it was like coffee. I'm like, oh, good. At least I don't have heart disease, right? Isn't that what coffee is supposed to help?
I think, Eric, you would contradict this interval because you would be way above it.
Yeah, probably. Oh, we could calculate how many gallons a week is that really fast. 77 divided by 52.
You would be the unusual plot point.
There we go. Yes. Oh, okay. My only solace is that at least it's not Red Bull. I don't know, or Monster or whatever those ones are. So we got these 12 minutes left. We've covered the main things. This question might be a little weird for you all. I know you look at it in the notes, but we don't do it a lot. Oh, nice, Sarah. Yeah, 4 pots. Is that like the 32 cup pot or the, because I think I have that size, but I've been trying to limit it to 8, the 8 part, 8 cups, between 6 and 8. So just the reminder here, this isn't super important about the distinction between the T distribution and the Z distribution. The key is the larger N gets, the closer to the Z distribution the T distribution becomes. So the Z distribution is one of these, and then the there are 2 T distributions in here. And boy, is it going to be tough to see on your black and white printed ones. But I believe this red one is the Z distribution. Am I right or am I wrong? I could be wrong.
I think the Z is the blue one.
Is it the one with the least spread or the most spread?
Yes, it's the tallest one, and it has the shorter tail.
There we go. So I have it backwards. Z distribution. Note all 3 of these have a mean of 0. What's different is the spread. So as we increase in, we decrease the spread. Took me a second there. Which means exactly what Cindy said, right? That the thing is going to get what was it that we said that one time that I'm never going to forget? Short and wide is the most spread.
Oh,
And
she's
is it
not
the
here tonight,
tall?
so we can
tall
say,
and narrow is the least spread.
yeah, Becky's ex-husband, short and wide.
So is the larger the Z distribution as it gets taller, the less spread it has, and then the shorter, the more spread it has?
Yeah, so if you see this piece right here, this is where the spread is showing up. And this
Right.
very first line is the closest to this middle spot here.
Right.
Okay, I'm gonna erase that,
Which happens to be the tallest one.
which also happens to be the tallest one, yeah.
Okay, so, okay.
So then the n equals 6 is going to be the next least spread or the next tallest one. So it's the yellow. And then the red would be, whoops. So I said the correct thing and wrote the wrong thing. Ooh. But I'm changing. That would make this one the 3. Not a super important thing to know, but it's good to keep track of kind of where this stuff comes from. Because I know you all are so excited for your masters in statistics. Hey, we just did this question. This is the exact same question we just did. Here's an X bar. Here's an E. Go nuts. Now, what I want to do is skip down to 3. What is this graph?
Normal
Box, is it
probability
box?
Oh,
Okay.
so this is the box plot, and then the other one is the normal probability plot. Good. Note that both of these look approximately linear. What's up with the box plots?
Why are we
T
talking
interval.
about box plots again?
Right? Tell me what this is.
An outlier.
Good. Oh, wait a minute. It seems like, nice, Alexa. It seems like if I were to go back here and read the condition, it would say, hey, the graph shows normal with no outliers.
So the first one, the T interval can be constructed, but the second one is not.
Nailed it. Yes. It's approximately linear. Okay. I said I was going to be picky about this, so I better at least have the decency to write it down. The normal probability plot is approximately normal with no outliers. We wouldn't have been able to tell whether there are outliers or not without the box plot. So the box plot tells us there's outliers. So
Shouldn't it be
here,
approximately linear with no outliers?
yeah, isn't that what I said? See, thank you. Thank you. Can you all just like taste the end of the semester? Maybe you can smell it. It's the same thing, right?
I've been ready since midterm for the end of the semester.
Oh, we only have like the most exciting stuff to go.
My brain can't take it.
Your brain can take it. You could do it. You can do it. I know. We're tired, and here's the worst part. We're gonna go on Thanksgiving break pretty soon, and you're gonna eat a ton of crazy food, and then you're just gonna have Christmas on your mind, and you're gonna have to show me that you can do a hypothesis test. Which in some ways the hypothesis test is more straightforward than these, because we give you a script and we say, do this first and then this and then this. Do these 6 things and you're done. It's a nice little checklist. If you like that, you'll be good. So to be clear, no outliers. There's an outlier. So it's not, that outlier messes with things. Okay. Yikes, did we do all of everything? Well, that was everything for the number 2 worksheet. And then we did everything except for number 1. Which, if you need help with number 1, look back at what you did for number 4. Same thing, just looks a little different. And don't forget for letter D, your formula. Sea level is equal to, now in this case, notice how I gave you alpha. It's a decimal, not a percent. So here we want to use 1 minus alpha instead of 100% minus alpha. An easy thing to mess with or to mess up. Okay. I feel like we've had enough.
So
Bless
you
you.
guys remember, we did not do the 9.2 worksheet number 1, which is my worksheet, but Eric did it this morning. Some of you will have already started it. If you were in my class last night, we did start it and can kind of give you some hinters. I like that word. Gosh. We gave you some hints on how to finish it. And so I'm not going to go through, we're not going to give you the time to go through and do it tomorrow. So if you want to check answers, like, or if you haven't started it and need to go through it, check Eric's morning video.
And I did write down tonight. I haven't been writing down every answer because I'm kind of thinking that might hold you a little more accountable to writing it out yourself first. I did write down every answer this morning for 9.2 number 1. So I think there's, yeah, I think I wrote them all out. Okay. I would like to say good night to you all. Have a great rest. If you have questions, stick around. You'll do 9.4 tomorrow and we'll be done with chapter 9 and then hypothesis tests. And then you've learned everything for the semester. We just do it again in chapter 11.
I will.
You will.
Yeah, y'all have great weekends. You'll see Cindy tomorrow, but yeah, good night. Good night. Great work.
Good night, Alexa.
I'm going to stop the recording and I will